In this unit, we talk about how to do query optimization. So, and I talked about this in the lecture, right? A lot of times as a DBA, we're expected um, to try to optimize our database and make sure that we're running at optimal performance and that we've got, all the features that we need are turned on to make sure the database runs as well as it can. And I want to talk about just some of the practical things that we can do for performance to enhance the performance of our database. So one of the first things that I want to do is talk about some of the tools that we have, and we've already talked about in this course the slow query log. So I want to review that real quick. So if you recall in our servers, I'm going to do it on the top here. Let's take a look at our config files. So let me just check and see what directory I'm in. I feel like I'm always losing my internet connection in these videos. I apologize. So my current directory, I'm in home be green, but I have to log in order to edit my config files. Of course, we have to be a root user. So let me just change to root. All right, and then we're going to get into, if you recall, our log files, or I'm sorry, our config files are in etc MySQL, and then I want if you recall, the config files for MariaDB are in MariaDB config. So we're going to go into mariadb.config.d. And then we have 50-server, which has most of the settings that we're looking for. So I'm going to use VI to edit it, right? VI always works in most Linux distributions. So it's good to be comfortable with that. So, and if you recall, we set up the slow query log in a previous lab. So you want to make sure that that's enabled for this lab. We're going to need that slow query log. So in my system, I reset most of my stuff in here. So my slow query log, oh, it is on. Here we go. So you can see here my log files in MariaDB-slow. And just so I don't have to keep typing out slow, I'm going to, or MariaDB dash, I'm just going to call it slow.log, right? That's good enough. Just make sure the rest of these settings are similar here when you're doing the lab. So the slow query log equals 1, make sure that it's running, and then it's actually logging. The long query time, I set to 1 second. That way I don't have to construct queries that are overly complicated to get it to log something. The rate limit, I set to 1. That way it logs almost all of my queries, right? Instead of logging every 10 queries or every 100 queries. And then I also have log queries not using indexes. That way I can see any queries that are not using indexes, and I'm going to talk about indexes in this lab. We didn't talk about that very much in the lecture. I talked about what they are, but not how they work and how to configure them. So we're going to look at that in the lab. So just make sure these options are set, and then I'm going to write and quit the file. I am also going to restart the database. So systemctl restart MariaDB. All right, so I'm restarted now. So at the bottom, I'm going to bring up this this log file. So let's go into var log, and I got to go into MySQL. Oh, access denied, so I have to use su. All right, so there's my slow.log, right? So it created the log file, and I'm going to just tail it so we can see it in real time as we're running some queries. It says no. Oh, I'm in the wrong directory. It should be var log MySQL and tail slow log. There we go. So I've got some stuff going on now. All right, so at the top, the first thing I want to do is get into MySQL, right? So I can start working with it. I'm going to go into my college database, college scorecard that we've been working with in this semester and the previous. And I forgot that I have capitalization on there, so it's college scorecard. All right, so let's do a select statement, right? So select star from, I don't know, from school, right? And I'm going to limit it 0, 10. That way we're not sitting here all night waiting for it to load. All right, so it logged my query at the bottom, and I've got my query results on the top. Of course, it returned this query very quickly, right? 0 seconds. So why did it go to the slow log query? Well, if you look at the bottom at the slow log query, we didn't really talk about this in the previous unit when we looked at slow log, but you can see here full scan equals yes. So in the lecture, I was talking about full table scans and how full table scans take more time, right? So that's basically telling us that for some reason, this query did a full table scan. It did not use a temp table, although sometimes you'll see with these larger queries it does. The temp table is on disk is no, which is good, right? Because if it's on disk, it's even slower. If it's not on disk, that means it's in memory. So a temp table in memory is marginally better than a temp table on disk. Is there a file sort happening? No, right? But however, if I if I add a clause up here, so let's do order by, and we'll do inst name, which is the institution name, right? So now you can see at the bottom, we do have a file sort, right? So it's telling us that it did a file sort. We still have a full table scan, right? So if I'm trying to look for clues as to what's happening with my queries, the slow query log is a good way to do that. So what I'd like you to do for the first deliverable is you're going to make sure that your slow query log is enabled, right? So let's make sure that we're getting our slow query log and it's outputting that data. And I just want you to do 2 queries that show that we have a full table scan and that we have a file sort on one of them and no file sort on the other, right? So you can see that difference when we do that. So one of the outputs from the slow query log should tell you that that it did a file sort and the other one will not. And I should probably tell you that pretty much all the queries that we do from this database are probably going to do a full table scan. So you're going to probably see that for everything, no matter what we do on this lab. So go ahead and do those 2, pause the video and go off and do those 2 queries. And when you come back, we'll take a look at the next topic. So for the next part of the assignment, we want to construct a more complicated query. There's 2 approaches to this complicated query. What I want to show you is first, we already created a view, right? So if we show tables, one of these tables, let me scroll up so you can see it. I think it's one of the first ones. So if you use the database that I provided for the class, you're going to have a table called score data. Score data is not actually a table. So score data is actually a view, and we can see that. So we're going to show create, oops, not table, it's a view, right? Show create view school data. And I'm just real quick, this is kind of a really poor way to look at the output. You've seen me do this in a couple other sections, but I usually put /g on the end. It's a little bit easier to read when you use the /g. So if you look at this view is actually selecting from 2 different tables, right? So we have 2 different tables here. We have the, let's see, we have the school table, and we are also selecting from the locale table, right? So 2 different tables with a join. I want to do the same thing. I'm just going to manually do a join. So I'm going to ask you to write your own join. So we're going to do select star from, I'll start with school, and maybe I can join something like admissions. And just to make this easier, I'm going to put an alias on here. I didn't really talk about aliases for table names in this class, but hopefully you remember from our previous class. So I'm going to join it on a dot, and if you recall, the column that's the same in these tables is going to be the OPEID, right? It's the unique identifier for the school. So that should be able to adequately join these, right? So I'm going to join these together. I'm going to limit it to the first 20 rows. And actually what I'm going to do is I'm also going to sort this. So order by school ID. I think I've got a column called school ID. Let's see. So we're going to let this run. It's taking a little while. My goal was to create a long query. It looks like I may have succeeded here. So let me pause the video until it finishes. All right, it finally finished after 25.06 seconds, so it was a pretty long query, and I'll show you that query again by hitting the up arrow. So I selected from two different tables. I have an order by clause. I've got a limit in here. So I'd like you to create your own long query, right? Use maybe a different table. You don't have to use admissions in school. You could use another set of tables, any two tables that you like. And most of them you can join on OPEID, right? So a lot of these tables you'll see an OPEID. So any two tables that have an OPEID, you should be able to do a join. And then you're going to see, that you can put an order by, school ID or admissions underscore ID or academics. So almost every table has table name underscore ID for the primary key, which we've talked about in the previous course. So create your own query, go ahead and run it. Hopefully it's going to also take a while. It's going to show up in your slow log query, and you're going to see the same thing, full table scan, file sort, yes, and all that stuff, right? So you should see all that same information. So our next step, and we're going to make that with two tables, just writing down what I'm asking you to do here. All right, so the next step is we want to find out why it took so long to run this query. So one of the commands I talked about in the lecture is explain. So if you put explain on the front of the query, and again, I'll do this again for you, right? So if you just type explain, sometimes it's not the best format, right? That it's hard to read. So you could also use the \G if you want. You could do it either way. You can see mine actually looked okay. This actually might be more confusing this way. So I'll do it without the G just so it's a nice little table. So you can see here it's showing both tables. It did use a temporary table on the first one, and it did have file sorting. Then there was a where clause using a join buffer, right? So this gives us a little bit of information about what it's doing. And you can see here that under possible keys, it's set to null, and the key is set to null. And what that means is that there was no indexes in this join, right? So I joined these two tables, but there was no indexes, so it had to do full table scans. And this would be a clue as a database administrator. This would be a clue to me that I could make this query faster by adding an index, right, for these two tables. So how would I do that? How would I add an index? Well, we use the create command. So we're going to create an index. We have to give our index a name. The way I usually name my index, I use ix underscore table name. So I'm going to make mine ix underscore school, and then the column that I want to use. So in this case, it can be OPEID. And then the table name. So in this case, school. Now, one thing I did here, in theory, I could make this a unique index. So let me try that, right? So I'm going to make this a unique index. We talked about in the lecture that you have unique indexes. You can have indexes that are not unique, and then you can have full text indexes, which I'll show you in a minute. So a unique index means that you can only have one value for that index for each row. So for example, our primary key is a unique index, right? So that means the primary key can only exist one time in every single row, right? Which is what we want. But you can have other columns that are also unique. I think this is going to fail because we probably have more than one value for OPEID. And I think I forgot to put the column name here. So in parentheses, you have to put the column name. Sorry about that. There we go. So now it's telling us that there's a duplicate entry for the OPEID. In this case, it's telling me that 336800 appears more than one time as a value for OPEID, so I can't use a unique index. And I can tell you, if you go down this rabbit hole, you might think, oh, if I just eliminate one of those 336800s, so I only have one, then it'll work. But a lot of times, then you try to run it the second time after you delete those, and you find out there's another value that's repeating. So it only shows you the first thing it finds that repeats. It's not going to list all the values that repeat that it can't create the key. So once you see it one time, generally you're going to probably see it again. So we're going to get rid of unique. That way this is not a unique key and it should work, right? There we go. So it worked. It created our index. The next question is, how do I know what the indexes are? Well, if we show create table for school in this case, and again, I'm going to do \G, you can see that now I see the key statement. So after primary key, I have key, ix school OPEID is the name of the key. and then the key is on the column OPEID. And I could have had multiple columns for that key. It doesn't have to be just OPEID. I could make it a composite key, meaning it's a combination of several fields. So I could have included other values for it could have been OPEID and school ID for that key if I wanted to. And in fact, that would be a unique key, right? We could make that unique because the combination of the school ID and the OPEID would probably be unique. So you can, there's different options here. One other thing I want to show you is, let's say let's go back here to my actual SQL statement. So let's make this just a little bit more complicated. So this time I'm going to add a where clause. So after my join, we're going to say where institution name like Drexel. All right, so now we have a limit. We have it's ordering by the school ID. It's going to look for only a value where it's like Drexel, right? So it's going to be a little bit more complicated. Now this will probably run pretty quick, right? It's 0.04 seconds, right? So it ran really fast, which is good. But it definitely still did a full table scan. It definitely still did a file sort, right? It had to create a temp table. You can see we have a temp table as yes. And if we do an explain on this, so let's go back and put explain on the front and see if anything looks different. Right? So this time, notice in the explain, this time it's telling us that it did use a key, right? So for the school table, it used the OPEID key. The reason that we don't see a key on the other table is we didn't create one, right? So we probably should though, right? We should have a unique key on, what did I use? Admissions. Right, I forgot to create this. So we want to create two keys, right? We want to make sure that all the joins are using a key. And we'll explain this again. Yep, so now we have our keys, right? So that's a good thing. And you can see that under extra, it says using where, right? So on that first line, it's saying that there's a where clause that applied to that school table because that's the where clause was on a column from that table. And if I'm a DBA and I'm running this explain to see, what is in this query, what attributes about this query might be causing a problem, for example, I might want to go and check and see, okay, there's a where clause. What is that where clause and how could it affect the performance? Well, that's yet another value I probably want to do a key for. So if I'm a DBA, I'm going to probably go and look at my slow query log or my general log, right? Either one would work. And I'm going to look at the query in the slow query log or the general log, and I'm going to look for that where clause for that statement. And I'm going to say, oh, look at this. They're querying for the institution name, right? So the next question I'd ask myself is that a field that users would commonly be searching for? And is it advantageous for me to have an index on that field? Remember from the lecture that we don't want to have a lot of indexes because too many indexes are going to slow down certain operations, right? But we also don't want to, we want to make sure we have an index where they're necessary because it will increase the performance of the database significantly if you have a lot of records and it's a field that people are constantly querying on, right? So we could considerably increase the performance of the database if that's a common field that people are querying and we have a lot of records. So I do want to create an index on that field. I think that institution name is probably something that people would commonly, use for a query in our database. So to facilitate that, I'm going to add an index. Let me just use the up arrow so I don't have to do this too. Oops, I think, there we go. All right, so the column that I want to create the index is going to be on, or the table rather, is going to be school. And the column name is institution name. By the way, what I'm doing right now, where it says IX_school institution name, that can be anything you want. It's just a label for the index. It's a name of the index itself. It really has no function, right, other than as a label. So you can call it anything you like. I like to call mine, use a naming convention on all of my indexes where it's IX for index, then the table name, and then the column name or a list of column names. And I do that way. If I have a list of objects in my database, it's obvious what that is, right? I know exactly what it is because IX is my shorthand for index and so forth. Some database engines, you have to have unique names for the indexes, and you have a place where you can go and show all of your indexes, right? I don't know if MariaDB lets us show indexes, but we can certainly find out. However, for right now, let's create this index. Now, there's one other problem here. So if I just create an index, right? If I do nothing else and I just create this index, if you recall, indexes are kind of limited in some ways. If you create an index that is no other type of index, a % with the like keyword is not going to work. So you can't. So it's still going to have to do a full table scan if you create an index this way. However, if you make it a full text index, right? So if I add full text on here, that should create an index that is a full text index of all the school names, so that I can do a where clause that has a like, right? So with the wildcard, and there's other string functions, anything that's a regular expression, right? So anything that's searching for partial strings or lists of strings. And generally, anytime you're working with complex strings, you have to use a full text index in order to fully leverage the advantage of having an index. Now, if your users are doing queries that are where it's an exact value match, right? So instead of doing where like Drexel, if the users are always putting where equals Drexel, right? Then you don't really need a full text index. But I have a feeling that with a column like this would not be common. It's probably more common that we're going to be doing a partial match, look for a partial match. But maybe something like a phone number, there it's more likely that someone's going to put in the exact value of the phone number, right? Not like a part of the phone number, or a zip code or something like that. So now that I've done that, if I run this query again, which has our like statement in it, right? So now we have using where. It doesn't tell me that it's using that index, right, in the slow query log. So what would be nice is if we have some additional tools, which I'm going to show you in a second, some of the additional tools that we have. But here's what I'd like you to do is, number one, you created your long query already that uses 2 tables. You're going to submit the slow query log, and you're also going to submit the explain, right? So I want you to show me the slow query log first before you do anything. You're going to write this long query, show me the slow query log with nothing really going on in it, right, with this little table. Then you're going to add your indexes, right? So I want you to add appropriate indexes. So don't use my 2 tables. I use school and admission. I would like you to pick 2 different tables, so not school and admission. And write your query. That's complicated. It can be very similar to mine, right? It's going to be obviously a different where clause, a different order by clause maybe. Your limit doesn't have to be 020. It could be something else. But I'd like you to add what you think are the appropriate indexes, but also you're going to do the explain, right? So you're going to show it the slow log query. You're going to show me the output of explain after you run that query. Then you're going to add the indexes that you think are appropriate. Then you're going to run the query again, show me the slow query log after you run it after you've added your indexes. I do want to see what the indexes are that you added, right? So show me what indexes you added. You can explain to me why you added them if you like, with maybe a comment in the SQL code. Run the query again, get the slow query, and then also output the explain. So do the same thing. Then I'm also going to ask you to do one more thing. I have already in this database, I've got a view called school data. I would like you to do the exact same thing with that school data view. So you're going to run that school data view query. You're going to run a query based on school data. You can put a where clause in it. Do the explain statement. Look at the slow query log. Give me both of those in your assignment submission. And then I want you to create indexes that you think are appropriate for that table, that would make sense for that table. Some of you took Info 365, and you remember we used that view to create a small application. So you can certainly use that as a guide. If you didn't take 365 in this iteration, then you can sort of just do a thought exercise on what you think would be relevant and just try to defend your answer. But again, you're going to create an index that's appropriate for that view. A couple indexes, right? So that view has a join, so make sure you take a look at that join. I showed you the explain. And the way that you're going to show me the indexes that you've added is you're going to output the show create table for me, right? So when you output the show create table, I should see your new indexes in that after you create them. So you don't have to give me the create index code. You can just do show create table and I can see those indexes. So that's what I want you to do for this part of the assignment. And then when you're done that, come back to this video, and I've got one more thing that I want to show you that we learned a little bit about in the textbook. So finally, in your book, it talks about the Percona Toolkit, or PT, right? So it refers to it, in the command it's PT dash something. So the Percona Toolkit has some tools that we can use with MariaDB. It's really designed for MySQL, but it has some tools that we can use in MariaDB to analyze our queries. And one of them is the digest tool, and that's the one that's described in your book. There are other tools available as well, right? But in order to use it, you have to install it first. So to install the Percona Toolkit, you're going to use apt-get, because we're in. If you're using, the Google Cloud with the Debian, standard system, it's a Debian-based OS, so it's going to use apt-get. You're going to install Percona Toolkit. So if you run that, I already have it, so I don't have to install it. But in yours, it's going to ask if you want to install it or not. You're going to hit yes to install it. It'll put all the prerequisites in. It'll install it. And at that point, you'll have the PT query digest command. Oops. Right? And of course, by default, it's rating for standard in. My log is slow.log, but let's exit this. If you want to see the help, right, to see what you can do, I think you can probably run help. Let's see if it works. There we go. So there's all the options that we have available with the slow query log. One that your book talks about is limit. It talks about another one too. I forget the other option that your book talks about, but there's a whole bunch of, outliers. So your book talks about the outliers. It talks about limit. So limit basically sets the default value of how it uses, basically how it analyzes the standard deviation for statistics about the queries. But in any event, there's a whole bunch of options here that you can play with the Percona Toolkit. But what I'd like you to do is try using the Percona Toolkit to look at your slow log, right? So if you type PT query digest and then followed by either the full path or just the name of your log, I can just put slow.log because I'm already in the var log MySQL directory. If you're not already in that directory, you don't change directory to that, you'll have to prefix slow log with the full path to that, to that file, whatever you called it in your config file. But when you run the PT query digest, because we've done a bunch of queries already, there should be some stuff in our slow log, so it should have some data to work with, and you're going to get a bunch of stuff that gets output. So when you look at the slow query log, the first set of data is the overall statistics, right? So you can see in my statistics, it's telling me that the longest query execution time was 25 seconds. The lock time was 267 microseconds. That was the longest lock time. The number of rows, so we talked about locks in the lecture, right? This is how we can analyze what these locks look like, how long the locks are. The number of rows, the maximum number of rows that I worked with was 20. I never did a query with more than 20 rows, but the minimum was 1. That's when we did a query for Drexel, right? So it sent us the 1 row. The number of rows examined, right? So we did in total, it examined 38,000 rows. The maximum was 15,000 rows, and the reason it's probably 15,000 is because when it does a join, right? It's a Cartesian join until it applies the the logic in the join, right? We have no rows affected because we didn't do any data manipulation, right? We didn't do any update, delete, or anything like that. But if we did, then we would see it there, obviously. And then you have a standard deviation and the average and so forth. So it gives you lots of good information. It tells me here that 75% of my queries did a file sort, 25% did not. 25% of my queries were a full join. The other 75% weren't. So this gives you a little bit of information about, so for example, we were using a temp table 50% of the time, and 25% of the time it was a temp table on disk, right? So this is the overall statistics. And then as I scroll down, it's going to show me the most problematic query, right? So this is the query that was the absolute worst, right? So the absolute worst query took about 25 seconds. That's the first one I did. It was 99.7% of the time of all of my queries, right? So, I only ran a few queries. That's why that number is so high. But all of the queries I ran in the preceding examples so far, all of them took 0.3% of the overall time, but that one query I ran took 99.7%, which tells me that it was a problematic query. And then here you can see which which item it was. You can also use the query ID to go and look up which one it is in the log. And then down here, this is specific statistics about that particular query. So this shows me exactly what, so obviously this one did a file sort, it was a full join, and so forth and so on. It tells me that it was a college scorecard database. It even tells me what host name, the user, right? So all that information I need to know if I'm going to try to go and track down to see what happened, right? And it tells me that the query was 10 plus seconds, right? The distribution. So if that query was run multiple times, I could see, what in the majority of time, how much time did it take, right? I only ran it one time, so it only shows me one time here. And then down here, it shows me all the tables, right? So I can go and look up what those tables look like, and of course the actual query that was run, for that query. So lots of cool stuff you can see in here. What I'd like you to do is install the Percona Toolkit, do a query digest, run the command against your slow log after you've completed the rest of the assignments, and I'd like you to submit as part of your assignments, your assignment submission. You're going to submit the output of the Percona Toolkit for whatever query it is that you wrote that was your complicated query that was the worst one, right? So it should show up in here. I should be able to see that and compare it to some of the other things you turned in. So that's it. So that's all you're going to do this week for query optimization. So we learned about indexes. You learned how to configure and create those indexes, show them in the tables, how to analyze whether we need them using the explain command in the slow query log. And then finally, we use the Percona toolkit to try to analyze some queries. If you have any questions, let me know. Thank you.